Okay, let's have a class. Sorry, a little delay. And exam 2 grades will be posted onto eCampus start from Thursday. Okay, so just a little bit delay. Exam 3. This section we will talk about biochemistry, basically. The biochemistry and the genetics. So what is going to be the outline? We will have lecture 1 to 2. We'll talk about biochemistry. This will be the key here. We are going to go over fermentation, glycolysis, citric acid cycle, briefly, but somehow maybe a little bit detailed. Then the key thing is calculate ATPs generate during aerobic respiration. That will be the key. Then we will have lecture 3 to 5. We will talk about DNA replication, transcription, translation, basically the central dogma and lacto-operon. That will be the outline of here. Relatively to generally speaking, if at the same time you are taking biochemistry exams, biochemistry class, genetics class certainly will help. But don't take it for granted, because here our focus is on bacteria, which means prokaryotes. In the other classes, when you talk is eukaryotes. Lots of the material are similar, but a little bit different. And something I will be mentioning much more details than what you learned in the other classes. Sometimes I will be briefly. It depends. So, if you are taking those classes, very good. But don't take it for granted and say that just simply move all the material from other classes to here. We will offer lots of extra points for the exam 3. What are we going to do? I'm telling you right now, you can go ahead to prepare. Extra points will be huge. Okay, number 1, glycolysis and citric acid cycle, I should say cycles, chemical name, and structure. This will be 0.5 points for each name, 1 point for each structure. So, if you're writing glucose there, you get 0.5. You write pyruvate there, you get 0.5. So that's easy to do. Okay. Second, all side chain of 20 amino acids. Because we're going to talk about the translation, we're going to talk about that amino acids, all side chain of amino acids, 20. We will all go over this detail in the lecture. Then I'm also going to filming the separate section when I teach the first lab. So 9:30 lab, I will be filming these two separately. Each about like 15-20 minutes. I did it before. And I will put on the eCampus so you can review. So you can do a calculation how many extra points there. Tons of, maybe like 30 or 40, at least 50 sometimes. Okay? Why I wanted to do this? As a good undergraduate, graduate from a great school, WVU, and you should know these basic knowledge whenever you go. And I believe you're going to learn these again and again in different classes. If you didn't learn very well before, why you not just spend some time here to make yourself strong and be those knowledge. Okay, then last time when you see, you're not going to be bothered you too much, you're not going to be troubled. So that's the purpose for this. So you have a lots of points to make up here. If you didn't do very well in the exams 1 and the exam 2. Plus, we have a final thesis writing, which is a sexually transmitted disease. So there's lots of the points up in the air for grab. It all depends for you. Okay, so no matter how great you are so far, there is a lots of opportunities there because I believe the opportunity for all the students. Okay, so that's something about the outline. I need to use this space, so I'm going to have to remove these. But I will mention this periodically when we go through these sections. So the next couple of lectures will be a little intensive, but we will explain as detailed as possible to you. Okay. First of all, this class, start from today, we're going to talk about biochemistry. First one, introduction of metabolism. So the first question is very simple. Metabolism. What is metabolism? You always remember there is a two section, catabolism and anabolism. Catabolism, large molecules become small molecular. Hydrolysis, lysis, going through biochemical reaction. The idea is to generate energy. Of course, it is ATPs. Anabolism, when all those small molecules synthesized, you have the ATP, you're going to use it to make those large molecules or macromolecules. So this is we call it's consume energy, consume ATPs. These two has to be coupled in the very short period of time of bacteria. They are not disconnected. If they are disconnected, then the bacteria will be died. Same as human beings as animals, so always remember. Metabolism, including catabolism and anabolism, they has to be coupled. At the end of the day, they will expressed as electron transfer. So we will mention these. Okay, this is the first concept. So I'm not going to read over all these things. You can read. If you don't understand, this will be a very good slides for you. Like a cartoon movie. Catabolism, energy, glucose become acid, carbon dioxide, waste products. Then the energy generates, then the nutrients come in, some subunits, then become cell structure. That's anabolism. Now in this class, we will focus on catabolism. We will not talk about anabolism because that's another class, is microbiology physiology. That's a microbiology major students will talk about more. And we have a limited period of time, so we will talk about catabolism. Anabolism will be very briefly mentioned or not mentioned. Okay. So this move on to our first question. Thermodynamic. Okay, thermodynamics, this is a theory coming from physics. Little bit difficult to understand because it is a physics concept used to explain biology or microbiology activity or phenomena. So we'll try our best to do. Thermodynamics is two theories. Number one theory is easy to understand, which means energy, I use this to express it. Energy never created or disappear, only transfer. If we talk about the biology activity or microbial activity, most of the time is potential energy become kinetic energy. So you may not understand this very well. What this means, I give you a very simple example. I have a ball here. This is a ball. and I have a car here. Okay. Once the ball goes down, this car gonna start to move. The ball is very high on the top of the hill. There is a potential energy. What is the potential energy? I'm not sure you learned in the physics. mgh. Then the car will start to move. That equals kinetic energy is like this. So at the end of the day, if you do a calculation, 2gh, which means how fast the car moving is rely on the height of the hill, is not rely on how big, how heavy is the ball. Okay? This is just a physics. I'm not going to mention this. It's not a physics class. So just tell you this potential energy becomes kinetic energy. That's the first law. That's easy to understand. Second law. Disorder increase. If you want to say very simple, you can read it. Amount of disorder in the system, blah, 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 they can talk a lot. Disorder increase, which means entropy increase. So this is understandable. In our body, you have a glucose in organized status, then become a small molecule, from organized to unorganized status, and you have to put them back at the end of the day because keep the balance, otherwise the bacteria will be died. So I always say, this disorder will be accumulated, but you need to become order. If the disorder is accumulated and at the end of the day, you cannot control, then the bacteria will be died. So easily understand. So that's the thermodynamic, the two rules. These two rules, if you want to talk about more, then become a very tricky question, which is a Gibbs free energy equation. And we will spend a little bit of time to talk about that. Okay. Gibbs free energy equation is delta G equals delta H minus T and delta S. Why we want to talk about that? Because in this class, we will talk about a very easy and important concept called substrate level phosphorylation. It comes from here. So that's why we want to spend some time to talk. So what is delta G? Delta G is we call free energy. And I want to tell you one thing. This is a little bit difficult to understand. What means free energy? It should be saying free available energy for bacteria to use. And then people think you're smart, so they took this out. Same as chocolate agar, they become free energy. So that's a free available energy to use. Okay, what is delta H? This is N sub V. Okay, this is tricky. What does this mean? This means heat content in a closed vessel at a fixed, I would say fixed pressure and volume. It is a thermodynamic concept, and we will explain to you later, okay? What does T mean? This is another thing that's tricky. Z is a temperature international unit. It means Kelvin. It's not degree Celsius. It's not degree Fahrenheit. So what is that? Minus 273 degrees Celsius. International units for temperature. Only using for physics equation, not using our normal life. You never say anybody tell you it's 5 Kelvin degree never heard about that. Okay, because we don't use it. Now what is delta S? Same thing right here. That is entropy. What this means? Energy cannot be used and used to measurement of this order. Because of this Gibbs-free energy equation, people come out with three important conclusions, which means delta G, if it's less than 0, the biochemical reaction will spontaneously happen. So, spontaneous reaction will happen. If the delta G is larger than 0, the spontaneous reaction will not happen. So I just write negative. And sometimes delta G equals 0, which means equilibrium. And I want to tell you, you heard about this. Like how you write on the slides. Lots of people read it, and I read it, I wrote it. But do you understand it? I don't think so. What this really means? What's the story behind it? So usually physics class, biochemistry class, organic chemistry, biology 101, advanced nutrition, all kinds of things. And then you see these slides. That doesn't mean anything. Okay, what this means? I'm not a physics major, so I cannot use physics terminology to explain, because 200 years ago, these research did in a thermodynamic situation in a closed vessel. It's hard to understand. So I find a way to explain to you in some way we can understand very well. Okay, let's talk about the situation. So this is the formula. Let's talk about this delta G, delta H first. What does this mean? So we're going to go back to the ball question. Okay, I had a ball right here. The ball is on the top. And then its draw goes here. Okay, there is a little bit distance here we call it H. And there's a large one here we call it H. That's how high it is. Look at when the ball from the top of the hill go to close to the bottom of the hill, it can't do it automatically, is that right? It can't just falling off. So what's the difference? That energy is related to H minus H. But we're going through some of the physics formula. So how do you understand this? In this equation, let's do it again. Okay? This means if delta H is decreased, T and delta S are stay the same, then what happened for this delta G? Of course, it's less than 0. Is that right? So that's one of the ways to explain this equation. Is if the enthalpy is decreased, the spontaneous reaction will happen. That is what we explain for delta G. Now you're going to ask me, you will say this ball will not be automatically fall off. You need somebody to push it. Yes, we will talk about this later on, real quick. Okay? So, think about when the ball falling off from the top of the hill to a little bit close to the ground, the energy is decreased. It looks like the enthalpy is decreased. If the T and delta S is not changed, this delta G will be less than 0. That ball will be automatically falling off. That is called a spontaneous reaction. Okay, that's called spontaneous reaction. Now the second is delta S. What happened for delta S? This you could explain is a closed vessel. I have a block here, then I have all these chemicals, or you can think about these balls. This is a block. Of course, these are organized. Is that right? These are organized. If this block is removed, what's going to happen? These balls goes everywhere. They go everywhere. This means disorganized. So what that means, delta S increased. So go back to this formula. Delta G equals delta H minus T and delta S. Delta H is the same, stays there. T is the same. This guy is increased as a value. What happened? Delta G less than 0. Spontaneous reaction happens. Okay? So you go this way, from organized to disorganized. Spontaneous reaction happens. Okay, how about T? This is a little bit tricky. People don't a little bit hard to understand. How about T? And I give you an example. July 4th, did you play cherry bomb? You play cherry bomb, is that right? The bomb goes everywhere. This cherry bomb, if it stays there at a room temperature, nothing will happen. What you need to do? You have to lighten it, is that right? You have to lighten it. Like we light a candle jar. So what happens? When you lighten it, this T is increased. So go back to see here. Delta H minus T and delta S. Here, delta H, delta S stay the same. This guy is increased, the T is increased. The whole value is less than 0. So those are the 3 examples which is explained to you what this really means for spontaneous reaction. Now, this is from physics standpoint to talk about. From biology standpoint, we can also explain to you this situation. What is that? Okay, in your body, we don't have this ball. So this type of energy become in a biology life. It will be a chemical bonds. They connected together. Majority CH bonds. Is that right? Let's say the major energy resource is glucose. And in the glucose, we have oxygen. These are organized, okay? And the bacteria are going to use it. So they're going to break down. Then become what? Carbon dioxide. Become what? Water. And generate what? ATP. From organized to disorganized. This is well explained cellular respiration. So, cellular respiration. What's the value of delta G? Negative 686 kJ per mole. That's cellular reaction. Now, how we explain this guy? Which means spontaneous reaction cannot happen. This happens for some of the bacteria. We call it a photosynthetic pick bacteria. Let's say cyanobacteria. Those bacteria need sunlight as an energy resource. So what happens? You have water. You have carbon dioxide. You have so-called ATP right here. This is disorganized. At the end of the day, I'm going to do carbon fixing to become an organized status. This is organized it becomes. However, this reaction cannot happen because the delta G equals 686 kJ per mole. This is negative. This is positive. So what we should do, if the spontaneous reaction cannot happen, we need some extra force. What is the extra force? Sunlight. That's the extra force. Okay, so these are the examples. Could explain to you this formula, very important. Now, this is a physics concept. We don't want to talk about this too much. We're going to go back to see what it is related to the biochemical reaction. So this Gibbs free energy equation could also be correlated to biochemical reaction. There will be here. So what's that? Let's say I have a chemical A and B will generate C and D. And by the way, majority of the biochemistry reaction in the bacteria or our human body is reversible. This comes out with K equilibrium constant. That equals the concentration of C multiplied by concentration of B, which is the products, and divided by the concentration of the multiplication of the substrate. And what is the connection between these? This depends on the pH. So, if a bacteria culture at pH 7, which means it's a neutral file, most of our bacteria looks like that. The formula, the delta G, will have a standard equation.